So here's the kind of problems that you had on last night's homework, and I'm just going to remind you how they work. If this had been simple, like a to the b equals x, I think you'd all know how to rewrite it as a log. Log base a of x equals b. You go from here over to here and then over to here. Remember doing that? Okay, and the reason you can't just do that on this one, it is sort of that way. It's just got one little nagging flaw. At the very beginning, it's got a 2. How do I get rid of it? Divide by 2. I had kids come up and say, they'd have this written down, minus 2 on both sides. That's a really common mistake. Why can't you do that? Because it's a times right there. How do you undo times? With divide. So you divide by 2, and these cancel, and then you'd have 1/2 to the x over 3 equals 4. You write that part down. And now from there, it is an exponential. So all you have to do is rewrite it as a log. Log base 1/2. I'll get you started. And then you jump to the other side of 4 equals, and then you jump back over here, x over 3. And then this part, if this had only used a base of 1/2, I could just get the answer in my head. But if you're extra smart, you could figure out that 4 could be written as 1/2 to the something. What could that be? 1/2 to the what? Nope. 1/2 to the 8th? Nope. You're thinking about adding up a bunch of 1/2s. This is timesing. If I put to the second, you're at least getting close, because that's 1/4. -2. Because 1/2 to the -2 means 1/2 squared, which is 1/4, and then the negative makes it flip into 4. So there we go. So now I could rewrite this as log base 1/2 of 1/2 to the -2. And now why did I do all of that? Because this part being the same means that this part's the answer. So it'd be -2 equals x over 3. And from there I was amazed how many kids didn't know how to solve it. This is pre-calc, for Pete's sakes. You're trying to get the x alone. So how do you get the x alone? Do the opposite of that. That's a divide by 3, so you times by 3 on both sides. Final answer, -6 equals x. All right, I'm going to give you another one like that. This one you can use your calculator on. So that, which part where the calculator been really handy? Right there. If I could have just done log 4 over log 0.5, I could have got my answer of -2 really fast. So on this one, use a calculator. If you need to borrow one of mine, there's a couple up here. Make it fast, please. All right, so let's try another one. 3 parentheses 1/4 to the x over 2 equals 12. Anybody else need to borrow one? I still have more. I just hide them. Okay, come on up. There you go. All right, so what you got divided by 3 on both sides. Remember, that's how you start. Now you got this. Rewrite it as a log. Probably didn't even need the calculator if you're good enough at negative exponents, but even if you're not, you can figure it out with a calculator. Log base 1/4 of 4 equals x over 2. And I'm going to try to prove to you that you don't have to have a calculator for this by rewriting this 4 as a 1/4 to the something. Otherwise, I could have just taken log 4 over log 0.25. But 1/4 to the -1 would give me 4. So now I know what the answer is without a calculator. Negative 1 equals x over 2. And then from there, you just multiply by 2 on both sides. X equals negative 2. What if my life depended on it? Like, this is the only question that's going to, you know, if I get this right, I'm going to get a good grade in this class, and then when I apply to Harvard, I'll actually get in. And, okay, so if everything depended on this problem, I'd go back, stick in a negative 2 right there, see if this actually works. So what does this make, then? Negative 1. What's 1/4 to the negative 1? 4, and 3 times 4 is 12, and it works. Okay? So you can double check yourself, and it'd be very smart to do that. Take your answers and check them, make sure they work. All right. Another kind of problem. This is a no-brainer if you know what ln e means. So the final answer is 6, because what's this? 1. So 6 times 1, 6. And if you didn't know what that meant, you should change it to log base e of e, and maybe you'll recognize the pattern and go, oh, the answer is the exponent. So the exponent here is 1, and therefore the answer is 1. 6 times 1 makes 6. All right, moving on. What's the answer to that one? 12. And now the questions on the test, of course, are not going to be that easy, but you're going to use that in a problem like this. So you're in the middle of this problem. It looks really complicated, but a big chunk of it can just simplify. What's that equal to? So 12 equals x over 3, and the most common wrong answer I get is then the answer is 4. 12 equals x over 3. What's the final answer? 36. All right. Next one. This one, you got to know how to combine things too. You remember that that expansion and compression? Well, we got to be able to put these together. This is a plus, so it can be made into a log base 5 of something. And if it was a plus, what should I change it to? And multiply. X times 10 or 10x. And again, you wouldn't see that just all by itself. You'd see it in the middle of this. Not that. I forgot to add the problem. Okay, you'd see it in the middle of this. Solve that one. So you probably, hopefully by now, have written log base 2 of 5x, because see, this is a big plus problem, so we can make it into a times, equals 20. Then hopefully you knew that I'm not going to be able to solve it the way it is, so maybe I should rewrite it as an exponential. 2 to the 20th is equal to 5x. I'm really close. I don't know what 2 to the 20th is, except it's a really big number. And then I'm going to divide by 5, and then I'll have my answer. Somebody take 2 to the 20th and then get the answer, and then hit divide by 5, and then what is it? It's probably E something. 209,000 and, is there more? Thank you. What? Okay. All right. There we go. Moving on. Here's another one. Do you get how this has been rewritten? Was it rewritten correctly? Yes, it was rewritten correctly. Good. Okay. Now, a lot of people will struggle for a long time to try to figure out how to make 4 into a 20. So in other words, I really want a 4 to be there. If it doesn't just jump out at you on your homework, especially on the book, that means that you're not going to know it. You won't be able to do it. That one you can't write 4 to the something to make 20. So there, I mean, you could, you're just not going to likely be able to pull it off. So then what are you going to do with the calculator? Log 20 over log 4, and you pretty much got it. Yes? That's a good question. We don't know. It's still being made. The suggestion has been that it will probably not allow calculators, but the numbers like this would have been, for instance, this would be like a 16. Would you know what to do then? You just say, oh, 16 could have been 4 to the second, so my answer is 2. So you can do this without a calculator. You can even go like 4 to the x equals 16. You know what I mean? That to the that equals that. And just think it through and go 4 to the what makes 16? 4 squared. That's a 2. X equals 2. All right, so probably not calculators, but I don't know for sure because I'm not making the test. All right. This one. Does that look like a reasonable start for this one? 3 to the 20th equals x over 2. Oh, that's the one we just did, isn't it? What the heck? How did I go backwards by accident? Here we go. Here's the one hardest kind of problem. It's an R3 level question that you will probably still not be good at after today. And that's where it's log x, and that's another log x. I squeezed the word log in there. Because here, let me show you what it was before. Last hour I just started with this. Do you know how to do that? Because if you don't know how to do that, then you don't have a hope of solving this problem. Because this is the fundamental thing, and it's like, that's a quadratic, and you could graph it, or you could do something really simple and get the answer. What's the simple thing? Yeah, well, okay, you're multiplying it out. You could do that. That actually would work, but there's something super simple. Since it's in factored form, just tell me the answers. What's that? 4, and what's that one? 0. There's two things that'll make it equal 0, 4 and 0. Now, if you had multiplied it out and gotten x squared minus 4x equals 0, and then graphed both sides and see where they cross 0, you would have found out they cross at 0 and 4. The parabola would be like this, 0 and 4. So yes, you could do it that way. You could use the quadratic formula and use a as 1 and b as -2 and c as 0. That would have worked too. But the was all super simple factored for you there. So can you see that the answers are 0 and 4? Then what are you going to do when this is the problem? Log x minus 4 equals 0. You're going to think back to, oh, this is just like this kind. So I just set this equal to 0 and this equal to 0. Would you please, on your paper, write log x equals 0 and figure out what the answer is? What's x equal to? 1. Because there's a little base 10 here, and 10 to the 0, I'm rewriting it now, equals x, and 10 to the 0 is really 1. Do you get how this is 1? Let's look at the other side. Log x minus 4 has to equal 0. Add 4 to both sides. Log x equals 4. Solve that one. Use a calculator if you have to. Stay with me. Let's do the little base 10 that you can't see. 10 to the 4th equals x. And you don't need a calculator for that. It's a 1 with 4 zeros after it. Equals x. 10,000. All right, so the moral of the story is, notice when your log problem is really a quadratic. Because, did you get when this log didn't have a base here, it was really a 10? Okay, and then I just rewrote this as 10 to the 4th equals x. That's what you do to rewrite these. Remember that? Okay. Ten to the 0. You're doing this side over here where we had 10 to the 0 maybe. If you're getting 10 to the 0, I think you're doing something wrong. Just to rewrite this one right here, you go start with a 10 as your base, and then that's your exponent, and then that's the thing that goes at the end. So, okay, moving on. This one is another quadratic. And the red writing is how you would solve it. Do you see what happened when we went from the black line here to the red line here? What did I do? Yeah. I replaced the log x's with just x. I did a substitution. Wherever there was a log x, like this right here, I just changed it to an x. This was a log x squared, so I changed it to x squared. And now I can act just like it's a quadratic and factor it down and then get my answer, x equals -1. But then what did I have to do at the end? And replace the x back again with a log x. And then solve that. Log base 10, that's supposed to be 10 right there. 10 to the -1 equals x, and that's 1/10. I'm going to give you one just like that and see if you can pull this off. Again, the steps were you start by saying, okay, there's too complicated up there. Change the logs into plain old x's. Then you factor it. Then you get your answer. Then you take that and substitute the log back in and solve it from there. All right, see if you can handle this.
Would it matter if the square was on the x?
Good question. When you square logs, you put the squared where I put it. You don't put it on the 2. If you put the x here, or the 2 here, then the 2 would go down to the front and be a 2 log x. That's not the same thing. 2 times something is not the same as squared. That's why they put the squared where I put it. All right. It was a good question. I suppose other kids were thinking the same thing but didn't want to stop me to ask it. So thanks for being willing to stop me. All right, so there's a problem. If you know the steps I just took a second ago, I'm going to help you get started. Change your log x's to just plain x's. Rewrite it. It'll look like a quadratic. You've solved like 100 of those since 8th grade. Solve your quadratic. Probably factor it. Get your answer. But then what you'll have to do is plug the log back in at the end. This is the hardest kind, and this is probably why we have so many days of review before we have this test, because of the quadratic part. Okay, so your first step would look like this. Nope, no logs anymore. X squared plus 5x plus 4, and by the way, I didn't say it, but it's assumed has to equal 0, otherwise you can't do these. Then factor it. X plus 4, x plus 1. Hey, this is shaping up pretty good. Now I get my answers. X equals, change colors again. Let's go with black this time. X equals -4 and x equals -1. Why can't I just stay with that? Because it's not the right answer. I have to substitute the log back in. Remember, I changed the log into just an x. Now I got to change my x into a log of x. Log of x. And then I solve those two and I'll have it. That requires knowing that there's a little base 10 that you don't see. And it's 10 to the -4th equals x. So x must be 1 over 10 to the 4th, which is 10,000.
Do you want to start it like that, or can you start it like
I would accept either. And 10 to the 1 equals, -1 equals x, and that would be 1/10 equals x, or 0.1. There's my two answers. Steps. First, change the logs to plain old x's. Factor it like normal, get answer like normal. Then swap the x out for a log x again. Put the log x's back in when it's not so complicated, and now solve it from there. Solve it down, and you got to be able to handle things like 10 to a negative exponent. That is going to come up a lot. So, like, if I say 4 to the -3rd, what does that mean? 4, what's 4 to the third? 64. So what's the answer? 1 over 64. Okay, so what if I start out with 64? How can I write that as a 4? 4 to the third? Is that the same as 64? Yep. So what if it starts out as 1 over 64? How can I rewrite that as a 4? 4 to the negative third. Because 4 to the plane third would be 64. And then the negative makes it 1 over. All right. And the most important thing of all, you got to just be able to handle this and rewrite that as a exponential. So this would be e to the equals, there we go. So what if this had, x had been a 2? I wouldn't expect you to be able to do e squared in your head. You can use a calculator and type in e and then squared. You know where e is? I think it's above the divide key. Okay. All right, so there's some of these on your homework where they're just too brutal to do in your head. Grab the calculator, it's okay. The ones you'd be expected to know how to do are, again, things like this. This would be about as complicated, no, here would be as complicated as possible. That, and no, I doubt there'd even be this complicated on the test. And then it equals x minus 4. For as far as stuff you'd have to do without a calculator. Can you rewrite that as a 3 to the something? Yeah, you could. Okay, so then you're saying it's log base 3 of 3 to the negative 1/3 is equal to x minus 4. And why did I just rewrite it that way? Let me make sure it's right. No, 27. The negative makes it flip. 3 to the 1/3. No, that's not right. Yeah, I think it's 3 to the negative 3. Let me check that now. 3 to the third is 27. The negative makes it flip. There we go. So it's negative 3 equals x minus 4. And then what do you do to both sides? Add 4. And then I get an answer of x equals 1. What if my life depended on it? Would you check it? Would you check, if you could, check the bungee ahead of time to make sure there wasn't any weak spots in it right before you jumped off the bridge? Because your life depends on it. Remember, see that girl that ended up in the water with the crocodiles? Bungee jumping in Australia.
Yeah, I thought
So she bungee jumps, goes down like 300 feet, stretching, snaps. Bungee snapped. So it had slowed her down a lot before it snapped, but it just like snapped right in the middle of the thing. Or anyway, it was actually fairly up high. And so she ended up in the river with her feet tied together, of course, because of the bungee thing, right? And the river has crocodiles in it. And the river is flowing like downstream with rocks and stuff to bash her head on. So she survived. She's got a bunch of cuts on her, and can you imagine the like fear? Now all of a sudden, all the guys are up at the top of the bridge because they don't ever expect anybody at the bottom, right? So now they got to like somehow get to the way bottom of this bridge and run down the stream to try to find her. And can't believe she survived all of that. Anyway, she just has some cuts, and she looked a little stressed, but. Anyway. All right. So if I'm going to check it, yeah, good point. I started that for a reason. If I'm going to check it, if I put in a 1, that goes right here. And so that I better make sure then that this part equals negative 3. And then if I had a calculator, I'd definitely type it into the calculator, and I'd go log of 1/27 divided by log of 3. Otherwise, I can just see if I could rewrite this as 3 to the something. 3, would it be 3 to the negative third is what I'd be asking, because I know this comes out to negative 3, and yes, it does, and so I'm confident it works. Watch out for this one, though. Let's say that you came out with an answer of negative 2. And let's say that it worked and everything was fine. Why can't that be a negative 2? Because you can't have negatives here or here by definition. And so if you solved it all down and even seemed like it came out with the right answer, sometimes their right answers are not allowed because you can't have a negative down in the, what's that called, the base. And you also can't have a negative here in the argument. These can be negative anytime you want. That's not a problem. It's only this spot and this spot that can't be negative. Okay? All right. So today we have to, we already graded the homework. I'm lost. Graded the homework in this hour? I know we graded last hour. Okay. It's been so long. Now we have a bunch of time to work, like 20 minutes. And the assignment is page 331, 1 through 17 odd, 19 through 24, and number 27.